So, in the last class what we studied about the principle of operation of the token ring, that is the 802.5 MAC control protocol and its frame structure. So, in the frame structure what we first we studied is the principle of operation and the frame structure. In the frame structure of 802.5, as we saw, there are two special fields, the second byte and the last byte. There are two special fields. So, the second byte what we saw is the access control field, and the last byte of the frame that decides the frame status. This is a kind of field that also work as a kind of acknowledgement for the sender. Let us say you have the ring, the sender is sending the frame and here is the receiver. Now, when the frame is passing through the ring, it comes to the receiver. If the receiver is down by any means at that time when the frame visits that station, what will happen? It says that the station is down or is not accessible. Station not accessible. That could be one case. Second case could be the station is active, but it is busy in doing some work, or the buffer of the station is busy or it is filled, so that the frame that come to this receiver could not be copied into the buffer. That means the case 2 will be the station is active and the frame, but the frame could not be copied. This is a second case. And the third case is a successful case. The station is active and the frame is copied by the station. So, the third case successful. So, to indicate these three conditions of the frame received by the receiver, the frame status field has two fields, two bits you can say. One is the access bit, another is the copy bit. And the status of these two bits will indicate the kind of acknowledgement to the sender. If it is 00, that means the station is not ready or it is down. That means it could not be accessed, forget about the copying. If it is 1, but this is 0, indicates the station is active, but could not be copied for some reason. Another case is 1, it is active and it is copied. So, when these two bits are set by the receiver and again comes back to the sender, the same frame with the status of frame status indicating 1 and 1 in the access and the control bit, the sender understands that the delivery of the frame is successful. So, it can immediately drain down or it can destroy the frame. But if it is 10 or 00, in both the cases what it does, it can keep the or it can store the data for a while for what is the purpose of storing it? For retransmission. So, that kind of acknowledgement is solved by a special field of frame status in the frame structure of 802.5. Now, we will look for the ring maintenance. How the physical ring or the token ring is maintained. The first case is initialization. How a ring is initialized? We know that the ring is nothing but a point to point connection of the interfaces, and these interfaces are connected to the nodes. So, when the ring comes up first with all its interfaces, and these interfaces see for a certain time period that the channel is having no tokens for a certain period, it understands that there is no monitor yet elected in the channel. So, what they do, whoever realizes this, that there is no token present in the channel, he sends a message claim token and waits for the claim token frame to rotate the complete ring and comes back to himself. If it finds as it is condition without destroying, that means none of the nodes are ready to be the monitor. In that case, what it does? It becomes the monitor now, and he also becomes the token holder. So, that means during the ring initialization period, a monitor is selected, a token is generated, and the monitor himself becomes the token holder and starts the transmission. and for how long it can transmit for the token holding time. And this token holding time could be enough to transmit its all the frames generated, or it may not be. So, either the token holding time will be, it will expire fast, or this can finish its transmission fast. In any of the cases, what that, let us say this is the monitor, if in any of the cases the monitor drains out all the frames that it has released into the channel, and it regenerates the token into the channel, leaving someone to seize it if ready. If they reserve it, in any case someone will capture the token and it will become the next token holder. Second is deletion of a node from the ring. What we know that the ring contains only the interfaces, not the nodes, right, and each interface is connected to the actual node. Now, there are two cases, either the interface is getting power from the ring or it is getting power from the node. If it is getting power from the ring, then shutting down of the node has no effect on the ring. The node may come up, node may get down anytime, interface does not have to do anything with that. But if the interface gets the power from the node, so shutting down of the node must need the interface to be switched off and the input of the interface and the output of the interface to be connected. Why this is required? To remove the 1 bit delay. So, this 1 bit delay will be removed because the interface was getting the power from the node. So, it is not going to get any more power from the node, that means it cannot generate the 1 bit delay, and if cannot generate, then this input and the output still has to be broken and they must be connected, so that the rest of the ring remains as it is. That is what is your deletion of the node, initialization and deletion. Then another case is the monitor bit. Let us say what the monitor does, it looks for the some of the maintenance cases like handling a garbled frame, it can handle an orphan frame, it can regenerate the token. So, when such situation will come? When you have a garbled frame, when you have a orphan frame, and when you need to regenerate the token. Let us say in the ring a frame is rotating, this is the sender who generated the frame, and once the frame is generated, it is rotating in the frame and the sender was supposed to drain it, but before it comes back to the sender has gone down. In that case what will happen? Now, no one is there to drain out the frame. What the frame will do? The frame will continue to rotate in the frame, in the channel, and this will be noticed by a node who is a monitor, because the monitor bit is set to 1 during the first visit of the frame through this monitor. So, when the same frame is rotating multiple times, the monitor understands that this is an orphan frame, no one is there to drain it out. So, now it is the responsibility of the monitor to drain the frame and regenerate the token This is the first case of orphan frame. Another is the garbled frame, a damaged frame. Let us say frame is rotating inside it, the frame, and the sender is not able to understand that the frame has been damaged. So, who can notice this? Again the monitor. And how it notices the garbled frame or the damaged frame? By the checksum field. When it notices that checksum field is having some problem and this is a garbled frame, again the monitor drains out the frame, again regenerate the token, right. And another role of this monitor is, we discussed in the last class, the delay bit. To hold the token of 24 bit in the channel, it is required that at least 24 bits of delay to be generated, and this delay should be equal to your 1 bit delay generated by the interface plus the propagation delay. Let us say if all this addition of the delay that is being generated by the ring is still less than the required delay, that is 24 bit delay. In that case, it is the responsibility of the monitor to introduce the extra delay. The monitor should introduce the extra delay to hold the token inside the ring. That means once the monitor is selected, it is the responsibility of the monitor to take care of the ring or to do the maintenance of the ring till the transmission of the frames are completed by all the nodes. Now, let us say the monitor goes down. This may also happen. How it is understood? The monitor has gone down. I am sorry?
Token frame has not been generated for a long time, and into delta t time has passed, and there is no new token in the ring.
But the token is existing, suppose. Let us say here is the monitor, here is the sender is generating the frames and the frame is coming to the sender and he is draining out and he regenerated the token again. That is possible. So, how somebody comes to know that the monitor is down?
The monitor bit is not 1 when the
First condition is the monitor bit is not set to 1. Yeah, any other option? The monitor bit not set to 1. So, when this sender drains out the frame, it sees that the monitor bit was not set to 1. First he realizes that the monitor is down. He can retransmit the frame again to see whether the next time the monitor bit is set to 1 or not. Again, if this is also not done, then this fellow sends a claim token, the sender next time sends a claim token, and again if at the same time somebody else can also send the claim token, again your reserve, the contention will be resolved and one can be the monitor, maybe the sender, maybe somebody else. So, that is how, and the token holder is down. This will be the case when the frame is what you said, when the token is not generated for a longer time which is equal to n delta t. Then the monitor understands that the sender or the token holder has gone down and it has taken the token along with it. So, now again the monitor regenerates the token. This is how the ring is maintained starting from the initialization of the ring and how the ring takes care of the token, how it allows the multiple nodes to handle with the priorities, how an acknowledgement is introduced, and another thing that the monitor cannot do is detecting the break in the logic, in the physical ring. This has to be done with a special technique called the wire center, that is a relay kind of thing. We are not going for those part, but this is a job that the monitor cannot detect. What it can see is only the status of the nodes connected to the ring, status of the token and status of the frames rotating inside the ring. So, this is what is your token ring protocol, or is a token based protocol, token bus and token ring that support the round robin fashion you can say, or a reservation fashion of MAC control. Yeah.
What if monitor and sender are same?
Hmm.
In the initialization case, when monitor and sender are
Same.
and it goes down, then who will play the role of sender, like in claim token and all those?
Let us say, yeah, good question, sit down. Let us say the first case, the sender himself becomes the monitor, right. Let us say another interface is there who is joined after this ring has been initialized, and this fellow is the sender and the monitor, and it goes down, it takes the node, takes the token along with it. What will be the case then? Timeout, that means this node and this node are waiting for the token to come to the ring, but it is not coming. So, for how long it will wait? N delta t, the maximum number of interfaces that could be connected into delta t. If they do not get the frame, the token during that period, they understand that the sender or the monitor or somebody, no one is there, the token is not at all present in the ring. So, he can go for the claim token, and the next time he can become the monitor. During this claim token again, let us say this fellow sends a claim token and this fellow also sends a claim token, and by mistake both of them got the claim token undamaged. So, they can claim this is a monitor 1, this can be also monitor 2, this can also happen in certain situations. Let us say by some means 2 monitors are selected, because this fellow found its claim token undamaged coming back to him, and this fellow also got the claim token coming to him undamaged. So, 2 monitors will be there, and when 2 monitors will be there, when one realizes that there is another monitor present in the ring, he himself withdraws itself. But again the case will be, it may happen that both are withdrawing. It is a very decent case. In that case again reinitialization. So, there are certain situations and you have to take care of all those situations what can happen at any point and how it is being handled. The only thing is that if a node, if a token is not available in the ring for a maximum time, waiting time, a token has to be regenerated, and who generates the token becomes the master, I mean the monitor of the token ring. Clear? So, what we studied till now about the MAC layer for wired network, right. So, this all what we studied is about the MAC layer for the wired network, and we have what we studied? We have a cable or a channel or a media which has to be shared by multiple nodes. If the cable is there and this cable is connected to multiple nodes, then they can go with a protocol of contention free, let us say contention based, then contention free, and another is token based. Every time what we studied is how a node gets a channel to transmit, that was the only question. We never thought of the interference, we never thought of the disturbance from any other node or nothing, no constraint of the bandwidth, nothing. So, what we studied? Well, a node, whoever gets the channel can transmit with the available bandwidth in the channel, and with that we studied about all the protocols, I mean standards from 802.1 to 802.5, being 2 being the of no use, 3, 4, 5 are the most important thing. But now you are working with a protocol standard, you must be knowing, that is IEEE 802.11, right. What is this standard? You say this is wireless standard. This is a MAC protocol for wireless. Bluetooth is a wireless communication, right. Your Wi-Fi is a wireless communication, WiMAX, cellular phone, anything, everything are wireless. So, does 802.11 supports all the kind of transmission? Does 802.11 supports all kind of wireless communication or a specific one? This supports a kind of wireless communication called sensor network is also wireless communication, that does not support, that is not 802.11. So, 802.11 starts with the WLAN or what we say the Wi-Fi network. Above this there were the changes for different wireless communications and you have various standards of that. Even 802.11 also has got the standard variation of 11A, 11B up to several standards. So, what we will study is the wireless LAN, the basics of the wireless communication and how the MAC protocol works for this wireless communication. So, when we talk about the wireless, the first concept is we do not have any cable now, there is no concept of cable. So, what is the channel? When I talk about the channel means what? I talk about the space or the air, this is the channel now, right. That means if a node is here and it is communicating with another node, then the communication is through air, and if air is the media, what will be the problem? What will be the constraints? First tell me what will be the constraints? Distance, good. Distance could be one constraint, meaning every node in a network has its own capability. How a node transmits? The node is connected with a radio, a transceiver which can transmit, which can receive, right. Now, what the transceiver does, when the node generates a frame, it starts or it transmits through the transceiver. This transceiver connects to the cable or the channel. I should not say cable, it is a channel. When the physical cables were there and this transceiver was connected to the cable, you have abundant bandwidth, and this cable was taking care of the length or the distance. As long as the cable has been connected, your nodes are connected and you can transmit to any length, 1000 miles or so you can connect it if you have the cable traced for that. But when you come to the wireless, there is no such cable is there and only air is the medium where the transmission can take place. Now, for how long the transceiver can transmit? It has a certain range, because every transceiver has its own capability, and this strength of the signal, or what you say, the amplitude of the signal, goes on fading as it covers the distance, that we know. The noise, attenuation, interference, everything will be there. So, after a certain range, certain distance, if the strength is like this, the strength goes on reducing and then vanishes. So, if any node who is present here, can he get the signal from this node? Not possible. So, the first thing what we consider is what is the transmission range of the node. That means till how long the strength of the signal generated by this node could be realized, could be processed. Because if it is too less, then also there is no meaning of receiving the signal. So, distance, or what we say, the transmission range, this is the term that we use usually, transmission range. It depends on the capability of the transceiver up to which it can transmit. So, every node you will see, there will be, if I am indicating a node, there will be always encircled with a circle saying that this is the transmission zone of this node. Beyond that, it cannot transmit, the signal does not go, or the signal does not have any meaning. So, somebody has to be there at this boundary, either to transmit further or to amplify it or to relay it, you can do anything. So, that is one constraint. The second constraint is, I am sorry, broadcast. Broadcast cable is also as a broadcast. Interference, right. In a cable, you say that one node occupies the cable, captures the cable. If he is a token holder, the channel or the cable is mastered by him. Or if he is winning in any contention free algorithm or contention based algorithm, he can transmit. That means the whole of the channel is given to him. So, no one is there to interfere. That is why we are having the contention free protocols, token based protocols, so that he should not get any disturbance or interference during its transmission or during its token holding time. But in this, can you restrict any node to transmit? It is difficult. We cannot restrict any node to saying that this is being used by somebody else, so air is being used by somebody else, so you do not do that, it is difficult. So, handling the interference is again another challenge in wireless communication, I agree. But the most important I am expecting from you is, what is the major constraint? Obstacles, that can be also considered as an interference. Obstacles that can, your line of sight can be changed, interference, the refraction index, those things, they will come under the same category. Who said this? Bandwidth? Yes, the major constraint is the bandwidth. In a channel, in a cable, if you are using a fiber optics and the node is getting the whole of the fiber optics or fiber cable, he is getting the whole of the bandwidth for its own transmission, abundantly available bandwidth for transmission. But when it comes to the wireless communication, this bandwidth is very, very less. Reason is that the available bandwidth, again has to be divided into number of spectrums, and a node coming under one category of network can have only a spectrum for its transmission, which is very, very less, and this bandwidth has to be used again by millions of nodes in the network, because when it comes to wireless and today's the scalable network, you can say the millions of nodes are connected. So, how you alert this small bandwidth, so that the bandwidth is alerted to a single node without any interference to transmit it, for how long it can be alerted, that is what is your another challenge. So, with this, your MAC protocol in the wireless LAN becomes very, very challenging and interesting also to see how a MAC protocol can work and how it will be handling the channel or the media to transmit. So, the MAC protocols for this, for WLAN. To understand these MAC protocols for wireless LAN, we have to understand first the architecture of 802.11. Fortunately, this remains same as your wired LAN. I mean the layers, the protocol stack remains almost the same. At the bottom you have the phi layer, above which you have the MAC layer, and this MAC layer has got supports two kinds of functions. One is the DCF and another is the PCF. DCF being the distributed coordinating function and PCF being the point coordination function. This is a central kind of, you can say, algorithm, whereas this is a distributed kind of algorithm. Meaning a kind of polling has to take place in the PCF's architecture. There will be one central agent or there will be a coordinator who will look after the allocation of the channel, saying which node can get the channel means the media at one point of time. And it is very difficult to handle such case because there will be many nodes and a single coordinator cannot do this. So, usually PCF is used when you have a small network, but the most important is a distributed coordinating function where your dynamic channel allocation algorithm can be executed and a node can be allocated with the channel. That is what is your DCF. In the phi layer or in the physical layer, the different kind of communication that is being supported by WLAN is your infrared. This is same as your a kind of communication like your remote, TV remote. How the communication between the remote to the TV is through infrared. So, that is a kind of communication supported by the WLAN. Another kind of communication is FHSS, the frequency hopping. Next what? Spread spectrum. These are all the different signal base that are being used for the communication, FSHS. The low range communications you can say. Another is DSSS. What is this? Direct sequence spread spectrum. These are all the spread spectrums, means a series of spectrums or a channel bandwidth will be allocated for this communication. And another more important kind of communication strategy that is being used by this is OFDM. This is orthogonal FDM, the frequency division multiplexing. Currently OFDM is a very popular kind of communication strategy. This usually all these are they are related to the phi layer and how the channel actually is being used by the upper layers. The signal, it handles with the signals, kind of signals, how they are being communicated by the upper layer frames or upper layers, that is being handled by this infrared and all this. Next we will see how the MAC layer or the FCF DCF work on this. We will see in the next class.